Hi everyone, this example problem is going to be based on the Framingham dataset. So if you would, please open the Framingham dataset in Stata now. We're going to be examining the distribution of total cholesterol at exam 1. So the first thing we're going to do is we're going to take a look at the histogram. So if you would, go to Graphics, Histogram, and the variable we're interested in is total cholesterol 1. Click OK. Now from this histogram, it appears as though the data are right skewed. We have a long right tail suggesting that the data are right skewed. We don't see that much on the left. So the data are in fact right skewed and not left skewed or symmetric. Now we want to also take a look at the corresponding box plot. So what we're going to do now is again go to Graphics and this time select box plot. Once again, the variable we're interested in is total cholesterol at exam 1. Hit OK. And now we see the corresponding box plot. So as we can see, there are several outliers in the upper range, and there are very few outliers in the lower range, suggesting that the data are indeed right skewed. Now, judging from this box plot, as well as the histogram, would we expect the mean or the median to be higher? Now we would hypothesize that because we have these large outlying values, that the mean would in fact be higher than the median. So we can check this in Stata. So we're going to type the command summarize, total cholesterol at exam 1, comma detail. And our suspicions are confirmed. We have a mean of 236, and we have a median, which is the 50th percentile, at 234. Now we want to take a look at how variable total cholesterol is at exam 1. For instance, we want to know the standard deviation, the range, and the interquartile range. So once again from this output, we can find out the range. The range is simply the smallest observation minus the largest. And so these values here, Stata will list the 4 smallest values and the 4 largest values. Now to calculate the range, what we can do is we can use Stata as a calculator. So we can type display, the largest observation, 696 minus 107. And we have our range is 589. And Stata will also give us the standard deviation. So here's the standard deviation, 44.65. Now we also want to take a look at the interquartile range. And again, we have to compute this. So we're going to use Stata as a calculator again. We're going to type display. And now we want to take the 75th percentile minus the 25th percentile. And so that's 264 minus 206. And we can see our interquartile range is now 58. Now Stata gives us a list of displays, as you can see, a list of centiles over here. Now say we want a centile that isn't listed. Well, Stata allows us to do that. So what we can do is we can use the command centile. The variable we're interested in is total cholesterol 1. And now which centile do we want? Let's take a look at the 20th percentile, for example. And we see that the 20th percentile is indeed 200. And that's all for example 1.